to my YouTube channel Java by MK. So today I'm going to start Kubernetes, deploy e-commerce services into Kubernetes live demo. So as you know, I'm a Java developer and this is a Java channel, but Kubernetes, and there are lots of tech stacks which are so relevant and is referred as full stack development. So I will not only continue with Java. Along with that, I will also explore Kubernetes, Docker, AWS, and so many other topics, even Angular, React. So one of them is Kubernetes. So we will directly start to explore Kubernetes today. So I will try to make this video as basic as possible, not to confuse a lot of people. I will just try to explain in very simple way. So if I start with the today's agenda, then it would be like as you can see, we have agenda and the contents. So in the first part we will discuss on the introduction to Kubernetes, why Kubernetes and problem it solves, and its architecture, all the components, and we will try to understand as basic as possible. I will just give you some analogy which with which we can relate, and all core Kubernetes objects. Okay, so as we know that why Kubernetes uh, came into picture. So we know that any microservices, let's say e-commerce, then e-commerce will have multiple services of its own. So to manage all those services, it is very difficult manually, because because of scalability, low latency, and high availability. So all those scenarios is being handled by Kubernetes itself. So so as I mentioned, like as I said, that all the manual work of deployment of orchestration is being handled by Kubernetes. So as I mentioned, like we if we manually start working on all those services, then if one application, if one server crashes, then the application will went down. So we have to manually go and start the server. We have to manually monitor all the instances, all the servers. So lots of manual work is there, and even after manual intervention, we we can not maintain all the servers together. So uh, like app can crash, and there could be traffic fluctuations like this. So so basically, uh, that's why we use Kubernetes, because it solves lots of problems. So let's jump to Kubernetes architecture. So as you can see here, we have two parts. One is control plane and another one is worker node. I have just given one worker node, but there could be multiple. So if this control plane is basically brain of the Kubernetes. So it's the internal working of Kubernetes is complex in on its own. So on a higher level, I will explain what API server does, what scheduler does, what controller manager does, and what etcd does. So before I go on one by one, I will explain in very layman term, like what API server is. So basically, API server, any request which comes to Kubernetes, it comes first to API server. Okay. So before going into the architecture itself, like I will explain how Kubernetes works, right? Because if I explain how Kubernetes works, then all these components will be easier for anyone to understand. So so basically, uh, as this topic, as this e-commerce web application, suppose have four services. Okay, So first service is product sellers delivery, like this. So all these services we have, we can use Kubernetes to to provide orchestration to them. Okay, so similarly, if we look inside Kubernetes, we have control plane as the brain of the Kubernetes. Okay, so as I and explained, API server is the starting point of the Kubernetes. Okay, then we have scheduler. Okay, scheduler is basically decides, uh, is the decider. Okay, and controller manager is basically controls. I will explain in detail if once I go ahead. Okay, so uh, as I mentioned, like control plane is the brain. It manages cluster, and worker nodes is basically responsible to run the application. Okay, okay, so now coming back to this control plane components, we have API server, scheduler, controller manager, and etcd. Okay, and worker nodes have kubelet, kubeproxy, and container manager, container runtime. I will explain all this one by one. Okay, so basically, if we understand if we try to understand Kubernetes with simple analogy, then suppose Kubernetes is one city. Okay, then uh, pods will be one house, and the service will be the address, and we have ingress. I will explain what ingress is the main gate. Okay, so and controller is a school teacher. Okay, uh, and ensures correct number of students always present, and scheduler is classroom allocator. Okay, decides where a student should sit. Okay, next is service is reception desk, ingress is security gate for visitors. Okay, so basically what it says, suppose we have one school. Okay, and the school has multiple buildings. Okay, so if we try to understand from that perspective, then school teacher is controller, and